Hello, everybody. This is Mr. Strager, and welcome back to another Big Ideas lesson. Today, we are going to take a look at lesson 8.3, but I figured a good place to start would be to talk about what we've already done in Unit 8. So here in Unit 8, we learned that a parabola can have the equation, in standard form, ax squared plus bx plus c. And we've sort of learned what the a and c values can do. What does the a value change about our graph? Well, we know for a fact the a value changes the stretch and shrink of our graph. So if our a value gets bigger, we have a vertical stretch where it gets wider and taller. If our a value is in between 0 and 1, it becomes wider, like a bowl. And if it gets negative, it goes underneath, it flips. So we know what our a value does. It controls the stretch and shrink. Do we recall what the c value does for our graph? Well, the c value here controls how much up or down our graph moves, at least so as far as we know. If we were to control the c value, if it goes up, the parabola goes up. When it goes down, the parabola goes down. So far, A and C are very predictable in what they do. We know exactly what the numbers are going to do to change our graph. The B value is a little bit different. Normally, you might think the B value controls how much left or right we move. That would make sense given everything we know. Let's watch and see if our predictions are true about our B value. Let's click on this play button on the slider and see what happens. And what is happening? Yeah, it kind of moves left and right, but really, it's sort of doing its own thing. It's almost like our parabola is jumping up and down across the screen. It looks like when our B value is positive, our parabola moves over to the left. And when our B value jumps back to being negative, it moves over to the right. But it's hard to say exactly how much to the left or right it's moving. In fact, fun little fact for you, the parabola models the following path. If I was to change these settings up, it follows this dotted line. So if I was to press play again, it follows this little dotted line throughout. So the B value is not like the others. A and C, we can tell exactly how our graph is going to change. With B, it's a little bit trickier. Let's jump to page 257 in our student journal and see if we can make some sort of sense of this weird B value. So here we are jumping back to page 257 in our student journal. And we're going to review some of the rules that we know from this unit, as well as some ones that we don't. First thing is, we already know our graph opens up when a is greater than 0 and down when a is less than 0. When our a value is positive, our graph opens up like a cup. When our a value is negative, it flips upside down like a frown. That's nothing new. We already knew that fact. Big ideas. Something we may not have known is this, though. The y-intercept of a graph is c. This is a little bit different than what we're used to. We know that c controls how much up or down a graph moves, but we always sort of had our c value at the vertex. That's what was moving up and down. In reality, when we add a b value, our parabolas can get really, really weird. So instead, it's much more accurate to say your c value is your y-intercept, where it crosses the y-axis, not necessarily your vertex. Notice how our vertex is much lower. The c value, yes, tells you how much up or down you move, but it also tells you your y-intercept. This is the tough part, though. With our parabola jumping around all over the screen, it was sort of hard to tell where our vertex would be.
our vertex could be stranded off on the side of the graph here. It could be way down or very close but on the left side. Our vertex could be all over the place when you put a b value in there. So we need a way to track where this vertex is. And there is a formula that can help us do that. The x-coordinate of the vertex is negative b divided by 2a. You have to use a formula to figure out where your vertex is. So again, the vertex coordinates are x comma y. And to find this x-coordinate, we have to use a formula now. The formula is, take your b value, or I should say your negative b value, and divide it by 2 times your a value, and that will give you the first part of your vertex. We're going to talk about how to find the second part of the vertex in just a little bit. What else is important about that zone, though? What's important about that? Well, if we look at the x-coordinate of our vertex, it would be right here, right? And the y-coordinate would, of course, be right here. The x-coordinate of your vertex is also your axis of symmetry. So if you know what the x-coordinate of your vertex is, that number will be your AOS. That means your AOS is also going to equal negative b over 2a. And you'll see me write it with the negative up next to the b. It doesn't change anything. That's just the way that I have always written it. You can totally write it with the negative next to it as long as you remember to put it there. Let's do an example of this. Let's see exactly how this works in action. So, at the bottom of the page, in your notes section, here's what I would like us to do. I would like us to try to figure out what the vertex and axis of symmetry are for this graph. For the graph, for the equation I should say, y equals 3x squared plus 6x plus 2. I want us to figure out what the vertex is and the axis of symmetry. We know our vertex is going to be a coordinate pair, some number, comma, some number. And we know our axis of symmetry is going to be x equals whatever that first number is. But how do we find it? We have to use our formula, negative b over 2a. So, to use this, let's figure out what is our b value. In fact, what are all of our values in this equation? Well, our a value is the first coefficient on the x squared. So our a is 3. Our b value is the second coefficient, the one that's on the x. That's going to be 6. And our c value, our y-intercept, if you really needed to know, is 2. Our formula says, plug in the b value on top next to the negative sign, plug in the a value on bottom next to the 2. So we'll get negative, because that negative sign sticks around. Our b value is 6, so on top we have negative 6. On the bottom, we have 2 times our a value, which is 3. Well, what is 2 times 3? It's 6. So this is negative 6 over 6, which is just negative 1. You know what this means? It means we have just found the x-coordinate of our vertex. It's negative 1. Our vertex is 1 unit to the left. That also means our axis of symmetry will be negative 1. Very nice. But we're not quite done yet. Yes, we found that our x value of our vertex was negative 1, but how can we figure out the y value? Well, this is the good news. We already know how to do this. Since we know our x value here, if we plug our x value into this equation, we'll get out our y value. If x is negative 1, let's just figure out what y is, and that'll be our vertex. So, we're going to go and use this equation, but we're going to plug in -1 for x. So everywhere we see an x, we're changing it out for a -1. So this is 3 times -1 squared, don't forget the square there, plus 6 times -1 plus 2. We have to use PEMDAS to solve this. So we take care of exponents first. What is -1 squared? Well, -1 times -1 is just +1 again. So this is 3 times +1, because again, -1 squared, plus 6 times -1 plus 2. Now we can multiply. What's 3 times 1? Well, that's just going to give us 3. What's 6 times -1? But -6. And we have our plus 2 at the end. So all we need to figure out is what 3 minus 6 plus 2 is. 3 minus 6 is -3, plus 2 is -1. So it turns out our y value is also -1. That's a fun coincidence with this. All right. Here's what I'd like you to do. On the next page, there are 4 problems down near the bottom. I want you to try out these 4 problems. Problems 1, 2, 3, and 4 on page 258. I will be listing off the answers on this page in just a moment. So pause the video, see if you can get the axis of symmetry and the vertex. And here are all of the answers. Check your work to see if you did them right. There is one more thing we want to talk about, and that's the idea of a maximum and a minimum. The maximum and minimum values of a parabola are either the highest or the lowest points on them. So, for instance, if your parabola is upside down, you see how the vertex is all the way at the very top? We call our vertex a maximum if it's at the very top. Notice that when we go down, our vertex is the bottommost point. We call that a minimum. So if you're ever asked to find the highest or lowest point on a parabola, it's always going to be your vertex. A perfect example of this is problem number 14. This function represents the height in feet of a rocket t seconds after it's launched, and the rocket explodes at its highest point. Something to note that might help you with this problem is this. All projectiles, you'll learn this in physics, follow something called projectile motion. All projectiles go in a parabolic arc, an arc shaped like a parabola. Even our rocket. So here's the deal. We've got this rocket that's launched, it goes up, and then it explodes at its highest point. And we can imagine that if the rocket continued its path, it would have finished with a parabola. Instead of x, we have t, which represents time. So this might be 1 second, or 2 seconds, or 3 seconds. We don't know at what time it exploded. On the other axis, we have h, which is height in feet. And this might be 100, 200, 300 feet. We don't know. So our goal is to figure out when that rocket explodes and where it explodes. Here's the deal. Since it's a parabola, all we need to do is find the vertex at the highest point. The vertex will be t, the time it explodes, comma h, the height it explodes at. So all we need to do is use our -b over 2a to find the time it explodes, and then plug our answer in to find the height. Try this problem out, and we'll come back in just a moment. Hopefully, our answer should be somewhere in this ballpark. Of course, because I rounded my answer, yours might be slightly different. But it should explode after about 7.813 seconds, and it explodes at 976.562 feet by plugging in 7.813 in for t. Thank you so much, everybody. This concludes the lesson. I hope you have a fantastic rest of your day.